Hi, this is Jaswant. Today we are going to discuss a new topic in subject chemistry, that is atomic structure. First, what is atoms? We have already discussed that atoms are the fundamental building blocks of matter. Now, the atom word is derived from the Greek word atomio. What is atomio? Atomio means indivisible. Next, atom is the ultimate particle of matter. Now, next one, Dalton atomic theory. It was proposed by John Dalton. What he said and what are its postulates? First one, it is made up of small particles. What is that? Matter. Matter is made up of small particles. Next one, atom is the smallest particle of element. Next one, different elements have different sizes and masses. Is it true or not? First suppose let us take gold and let us take phosphorus. Those two don't have same masses, same sizes. Next one, atoms of different elements combined in fixed ratio to form molecules. Let us take an example for this. Example 1. CO. What is that? Carbon monoxide. The ratio is 1:1. Next one, CO2. What is that? Carbon dioxide. CO2. 1:2. Next one, it explains law of conservation of mass. We have already discussed about this. In a chemical equation, on both sides, reactant and product sides, it should have same masses. Next one, law of constant proportion and law of multiple proportion. We don't need to discuss about that. Next one, drawbacks of Dalton atomic theory. What is its first drawback? Does not explain why atoms of different or same elements combine to form a molecule. Previously, in postulates we have discussed that two atoms of different or same elements combine to form one molecule, and taken as example carbon monoxide and carbon dioxide. But he does not explain that why it combines to form a molecule. Next one, why atoms of different elements have different sizes and masses. Next, in postulates we have also discussed this point, but he does not explain this. Why different atoms of different elements have different masses and sizes. Next one, fail to explain internal structure of atom. In that, it does not explain the internal structure of atom. We know the atom, but does we know that there is another structure in the atom? No, but it is not explained that. Next one, why electricity is produced when glass is rubbed with silk cloth. Do you know that while you take a glass and rub it with a silk cloth, their electricity is produced. This is called law of multiple proportion. Next topic, subatomic particles. What are the subatomic particles? Atom consists of smaller particles like electron, proton, neutron, antineutrino, positron, antipositron, pions and mesons and so on etc. But electrons, protons, neutrons are considered as fundamental particles of an atom. Isotopes. What are isotopes? In same elements, but in their atoms they have different masses. Examples: 1H1, 1H2, 1H3. This is hydrogen atoms. One atom called protium have mass number 1, and deuterium have 2, tritium have 3. P means protium, D means deuterium, T means tritium. And there is also a second definition for isotopes. It has different neutrons, same number of electrons, protons, electronic configuration. EC means electronic configuration. Same position in periodic table. Periodic table also can be presented as PT. Next, chemical properties are also same. And different mass number. We have already learned in the first definition. What is that? Have same atomic number, different mass numbers. Next one, isobars. What is isobars? The different elements which have same masses in their atoms. For example, carbon, nitrogen, atomic number 6 and 7 but masses 14. Next example, 18, 19, 20. What are they? Argon, potassium, calcium, but they have same mass numbers 40. And another definition is have same nucleons, means the number of protons plus number of neutrons, and different electrons, protons, neutrons, physical and chemical properties. Next topic, isotones. Isotones means different elements, same neutrons. For example, carbon and oxygen, atomic number 6, and for oxygen 8, but mass numbers 14 and 16. How to count number of neutrons? Mass number minus atomic numbers. Let us see their neutrons. Here 14 minus 6. Carbon neutrons is equals to 8. Here oxygen neutrons is equals to 8. And that's why these are called isotones. And here they have same 23 minus 11, 12. 24 minus 12, 12. Neutrons is equal to for them both 12 neutrons. And next one, they show different physical and chemical properties. Next, isodiaphers. What is isodiaphers? Nucleides having same isotopic number. How to find isotopic number? Means mass number minus 2 into atomic number. Let us see one example. First, fluorine and sodium. What is the atomic number of fluorine? 9. Mass number 19. Next, sodium. Atomic number 11. Mass number 23. Let us find their isotopic number. A minus 2Z. This is for fluorine is equals to 19 minus 2 into 9 is equals to 1. For sodium, 23 minus 2 of 11 is equals to 1. Same isotopic number are called isodiaphers. And they have same isotopic number as we discussed here. And next, different electron, proton, neutron and chemical properties. What is isotopes? Molecule with same atomicity and same electrons. What is atomicity? Total number of atoms in one molecule. Now let us take some examples. CO2 and N2. CO2, carbon dioxide. N2, nitrogen. Let us count its electrons. 6 plus 8 into 2. 16 plus 6, 22 electrons. Here, N2, 7 into 2. Into O. 7 into 2 plus 8. 14 plus 8, 22 electrons. So, these are called isostars. Next one, isoelectronic species. What is isoelectronic species? Molecules or ions, but with same number of electrons. Don't think that before one and isoelectronic species is same. In before one we have said only molecules, but here we are also saying about ions also. Let us see one example and let us clarify our doubts. Example: nitrogen N minus 3, O minus 2, F minus, neon Na plus, Mg plus 2 and Al plus 3. All have 10 electrons, because 7 minus 3 means 7 plus 3. 7 plus 3, 10 electrons, 10 electrons, 10 electrons. We already know neon is having inert gas configuration, so it has 10 electrons. Na plus 10, Mg plus 2 10, L plus 3 also 10. 30 minus 3, 10 electrons. Very easy. 10 electrons, 10 electrons, 10 electrons, 10 electrons, 10 electrons, 10 electrons. Next example, P minus 3, S minus 2, Cl minus, argon, K plus, Ca2 plus. These all have 18 electrons. See here, 15 plus 3, 18. 16 plus 2, 18. 17 plus 1, 18. And argon, inert gas, 18 electrons. K plus, 19 minus 1, 18. Ca plus 2, 20 minus 2, 18. All have 18 electrons. 18 electrons, 18 electrons, 18 electrons, 18 electrons, 18 electrons and 18 electrons. These are the examples of this isoelectronic species. Today we have discussed about atomic structure. In that, first atoms, next Dalton atomic theory, and the final one subatomic particles. In that we have discussed isotopes, isobars, isotones, isodiaphers, isostars, isoelectron species. We have discussed all about this and got a clarity on this very neatly. Thank you.